Okay, students. Well, previous class I started electron affinity. According to what is electron affinity, students? Amount of energy released when an electron is added to the outermost shell of isolated gaseous atom. Okay. Now I told you the reason also. I explained the reason also. Why energy is releasing? Why energy is releasing while adding electron? Here, electrons which are present in inner shells repel this electron. So the added electron will be repelled by the inner electrons. Inner electrons. In that repulsion, some amount of energy will be released from an atom. So EA1 is exothermic. Next one more important. In ionization energy, what I say? Ionization energy is endothermic. There IE1 means removal of first electron. Whatever the energy required to remove first electron, that is IE1. To remove second electron, whatever the energy we use, IE2. IE1, IE2, IE3. That depends on how many electrons you are removing. Means number of electron. First electron if you remove, first ionization energy. Second electron if you remove from unipositive ion, second ionization energy. In ionization energy, all are endothermic only. Endothermic only. And I told you IE1, IE2, IE3. Out of IE1, IE2, IE3, which is more? IE3 is more. As we remove electrons by one electron, nuclear charge, magnitude of positive charge is increasing. Means effective nuclear charge on valence electron increases. So to overcome those attractive forces, we need to apply more energy. That is the reason IE1, IE2, IE3. If you see, IE3 is greater than IE2, IE2 is greater than IE1. This happens generally. Some exceptional cases are there. That depends on electronic configuration. Next one. Here, EA2, next. Factors affecting affecting electron affinity. Factors affecting electron affinity. First one is atomic radius. These are all general factors only. Some other exceptional cases are there, students. That also we'll discuss. Atomic radius. As atomic radius increases, tendency of attracting electrons decreases. Tendency of attracting electrons decreases. If it decreases, tendency of releasing energy also decrease. Amount of energy released also decreases. So from this, what we can say, electron affinity is inversely proportional to atomic radius. Electron affinity is inversely proportional to atomic radius. Atomic radius. But here problem is no in the groups periods when I while explaining that I'll tell you exceptions. General point generally you put here. Next, effective nuclear charge. Z effective also will call effective nuclear charge. As effective nuclear charge increases, tendency of attracting electrons also increases. Energy released will be more. Directly proportional to Z effective. This one also general. Next one, stable configuration. Stable configuration. You see students which are having stable elements which are having stable configuration, they are not ready to lose electron, they are not ready to gain electrons. So generally stable electronic configuration elements electron gain enthalpy or electron affinity is almost equal to 0. Even noble gases electron affinity is almost 0. Nitrogen electron affinity almost 0. Beryllium almost equal to 0 since they are having stable configuration. Okay, elements which are having stable configuration, those elements electron gain enthalpies or electron affinities will be less. Having less electron affinity. Elements which are having stable configuration, having don't want. Simply one in one sentence will write. Electron affinities of elements with stable configurations. are low. Electron affinities of elements with stable configurations are low or approximately equal to 0. 0. Example, noble gases electron affinity is almost 0. Noble gases electron affinities are 0. 0 approximately is equal to 0. Next, variation of electron affinities, electron affinity in a period and group. First one in period. In a period. As we move from left to right, as we move from left to right in a period, electron affinity increases. Why? Atomic radius decreases. Atomic radius decreases. So effective nuclear charge increases. So tendency of attracting electrons increases. So more amount of energy will be released in a period. Generally, it increases. Some exceptions are there that I will give now. In a period, from left to right, electron affinity increases because atomic radius decreases and effective nuclear charge increases. Both are favorable for electron affinity. But if you see here, second period elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Here, beryllium electron affinity almost equal to 0. Even nitrogen also almost equal to 0. So here what you have to write, increases from left to right. These are the exceptions. Star mark cases are there, no? Those are the exceptions. We know since here stable configuration 1s2, 2s2 completely filled s orbitals here. Here nitrogen atomic number 7, 2s2, 2p3. So p is half filled. So both are stable configurations only. So generally it increases. Some exceptions are there. Even electron affinities of noble gases is equal to are equal to 0. Next group, it is very very important, students. In a group, what I said, generally electron affinity decrease. Decreases in a group. Here also Few exceptions are there. If you take fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. Here, fluorine atomic number 9, its electronic configuration is 1s2, 2s2, 2p5. Here it is 3s2, same group elements, no, just the shell number you increase. Here 4s2, 4p5. 5s2, 5p5. See students, here second shell contains only two subshells. What are those two subshells? 2s and 2p only. D starts from third shell, and here P already it is carrying 5 electrons, so it can accommodate one more electron, only so much. Fluorine can attract only one electron, but if you go to chlorine, 3s 3p, in third shell there is one empty orbital, empty subshell, that is 3d. D starts from third shell. So here in P, it can accommodate one electron. D completely it is free, so 10 electrons. Fluorine to chlorine size difference. So not much difference is there in size. Only one shell difference is there. So attracting power is somewhat favorable to chlorine. At the same time, accommodation is there. Accommodation is there. So in that case, we can accommodate more number of electrons. Means chlorine can accommodate more number of electrons. If it accommodates more number of electrons, more amount of energy. So then bromine can accommodate still more. 4F is also there. That time accommodation power is there, but attracting power is decreasing compared to fluorine. Because 4 shells, size of the atom is increasing more. So that attracting factor is not supporting. In case of bromine, only one factor is supporting. What is that? Accommodation. In case of chlorine, two factors are almost favorable for electron affinity. Size difference is not much from fluorine to chlorine. At the same time, 10 electrons difference is their accommodation. So chlorine electron affinity is more than chlorine. If you go now, here size factor is dominating, decrease. This is very, very important. Electron affinity order is very important. So simply in P block elements, every 3p element, 3p element means last electron in 3p orbital, no, those are having more electron affinity than 2p orbital electrons. It's like institution is small, but it has very good name. That time more number of students ready to join. More number of students will be ready to join, but accommodation power is less. Has good name, but it institution can't accommodate more number of students. That time they get less amount only. Here energy I am comparing with the amount. So third institution, it is very big, but no name. Institution is very big, but so much name is not. So accommodation factor is supporting, but without name, without brand, who will join? Okay, so more number of students will not join, so more amount will not get. Bromine case, like more accommodation power is there, but attracting power is not there. Fluorine case, more attracting power is there, accommodation power is not there. But chlorine, so one more person started institution. First institution is very small, very good name. Third institution, very big, no name. So third person started institution, third institution, it's like it has somewhat good name. Enough name it has and enough accommodation power. Both factors are supporting in third case. By copying these two, he did. Means he observed the drawbacks of both institutions. By observing, he started another institution, has good name and has enough accommodation power. So third person can get more admissions, more amount than second and first one. Same thing, fluorine case also. In one case accommodation power is supporting, one case attracting power is supporting, but the third case both are supporting, like chlorine. So not only in this group, students, even if you take oxygen, sulfur, selenium, tellurium, in this case also same. Every second element in the p block elements more ionization, electron affinity. Nitrogen, phosphorus, if you take 15th group, electron affinity trend in different groups. So conclusion, what I want to write, elements which are having 3p orbital rather than 2p. So from this, what we can say, in p block especially, we can observe this one. 3p orbitals element has more electron affinity than 2p. Afterwards, order will be regular. From top to bottom, electron affinity decreases. From top to bottom, electron affinity decreases. So this order, I hope, so among all the elements in if 17th group, which is having more electron affinity, fluorine. See here, from first group to 17th group, electron affinity is increasing. Electron affinity is increasing. Again, from top to bottom, second element has more electron affinity. Then, from this, what we can say, 17th group elements are having more electron affinities. In that 17th group elements, which is having more electron affinity, chlorine. So, highest electron affinity element is chlorine. Important students. Element, not elements. Chlorine. Next side heading, electropositivity will write. What is electropositivity? Electropositivity is nothing but tendency of donating electrons. Tendency of donating electrons. Tendency of donating electrons is called electropositivity. Next, factors affecting this and all is affecting electropositivity. Factors affecting electropositivity. First one is atomic radius. Atomic radius. What atomic radius? How it influences the electropositivity? This is one atom. This is one atom. Here, two shells are there. Here, three shells are there. So, which atom can donate electrons easily? Which atom can donate electrons easily? So, here these electrons are there. This is one atom. Okay. So from which atom we can remove electrons easily? See here, first atom, second atom. Second atom we can remove electrons easily. We can remove it from that is ionization energy. This one is different. Itself it is losing electron. Which atom can readily loses electrons? Which atom can readily loses electrons? Obviously this one. Why? Size of atom is more. As size of atom is large, nuclear power on valence electrons will be less. So readily loses electron. Here, outermost electrons are loosely binded by nucleus compared to first one. So as atomic radius increases, electropositivity also increases. It is nothing but metallic character that is also increased. Metallic character and electropositivity, you can write same. So from this, what we can write, students? Atomic radius is electropositivity is directly proportional to atomic radius. As size of atom increases, atomic radius increases. So among all the group elements, first group elements are having large means more electropositive, having more electropositive character. Reason is from left to right atomic radius decreasing. Atomic radius is decreasing. So first group elements are having large atomic radius, so they are ready to lose electrons. They are highly electropositive. So first group elements are highly electropositive. Their metallic characters is more. Next, effective nuclear charge. As effective nuclear charge increases, electropositivity decreases. Because effective nuclear charge means charge nuclear force of attraction on valence electrons. If it increases, atom cannot lose electrons easily. So inversely proportional. Effective nuclear charge. Okay. Next, these two factors easily you can make out. Next one, variation of electropositivity in a period. Variation of electropositivity in a period. You know, from left to right, atomic radius decreases. Atomic radius decreases. As atomic radius decreases, tendency of losing electrons decreases. So electropositivity decreases. Okay, you can write as we move from left to right, atomic electropositivity decreases. Electropositivity decreases because atomic radius decreases. So electropositivity is directly proportional to atomic radius. We know electropositivity is directly proportional to atomic radius. So across the period, atomic radius decreases. So electropositivity also decreases. So in a period, from left to right, electropositivity decreases since atomic radius decreases. Only that much. Decrease. So among all, first group elements are highly electropositive. First group elements are highly electropositive. In that, from top to bottom again, electropositivity increases. So francium you don't consider because it is radioactive element. Leaving francium, next one before the francium, we'll get cesium. So among all the elements in the periodic table, cesium is highest electropositive element. Highest electropositive element. So highest electron affinity element is chlorine. Highest electropositive element is cesium. So by using this metallic and non-metallic characters also we can find out. Highly electropositive means highly metallic. Less electropositive means less metallic. Next, in a group. In a group. So in a group, from top to bottom, in a group, from top to bottom, electropositivity increases because atomic radius increases. Sorry. Electropositivity increase from top to bottom because atomic radius increase. Is directly proportional to atomic radius increase. So fluorine, beryllium, magnesium, calcium, strontium, barium. If you take barium has more electropositive nature. Increase. Second group elements. Just example. So from top to bottom, metallic character increases. Since side side now, electropositivity increases, metallic character increases. So from top to bottom, bottom metallic character increase. So metallic character increase. Here I am going to introduce one more point, students. Metallic oxides are basic in nature because they form on dissolution. Metallic oxides they form respective bases. Sodium hydroxide, if you dissolve it in water, it produces sodium hydroxide. Calcium oxide, if you dissolve it in water, calcium hydroxide. Those are all bases only. So metallic oxides are basic in nature. More metallic oxides are more basic in nature. Understood? So from top to bottom, basic character of oxides increase because metallic character is increasing. Oxide is common. As metallic character increases, basic nature also increases. Understood? Now, from top to bottom, these are all like applications only. Basic character of increases. Increase. If you see beryllium oxide, magnesium oxide, calcium oxide, see metallic character is increasing, basic nature also increases. You can decide like this, increase. It's like application on. Next side heading, electronegativity. Electronegativity. What is electronegativity, students? Tendency of attracting bond pair of electrons. Simply, some students will write like tendency of attracting electrons. It's called electronegativity. Bond pair of electrons or shared pair of electrons is called electronegativity. Or shared pair of electrons is called electronegativity. Tendency of attracting bond pair of electrons or shared pair of electrons is called electronegativity. So this is bonding property. The rest all are like isolated property. Individual atom we'll discuss. Here it is bonding property. So here AB is one molecule formed bond. If B is more electronegative, this bond pair of electrons will come close to this one. So this will get partial positive charge. This will get. So now this is the electronegative atom. B is electronegative atom. So its electronegativity is more. This property is called electronegativity. Tendency of attracting bond pair of electrons is called electronegativity. It is opposite to electropositivity. The tendency of losing electrons here, tendency of accepting electrons or attracting bond pair of electrons. It's called electronegativity. It is not isolated property, it is bonding property. So from the example you can make out. Bonding property. Next, factors affecting electronegativity, opposite to electropositivity. Factors affecting electronegativity, not positivity. First one, atomic radius. Atomic radius. How it affects students? Atomic radius decreases, effective nuclear charge increases, so tendency of accepting pair of electrons increase. One pair of electrons increase. So from from left to right in a period, atomic radius decrease. That's separately we'll discuss. So electronegativity is inversely proportional to atomic radius. So left to right, electronegativity increase. Next one, effective nuclear charge. Effective nuclear charge. Effective nuclear charge. So effective nuclear charge increases, tendency of attracting one pair of electrons increase. So it is directly proportional. Electronegativity is directly proportional to nuclear charge. The main factors. Next one, variation of electronegativity just in a period, variation of electronegativity in a period. I told in a period as we move from left to right, atomic radius decreases, electronegativity increases. Simply one sentence, increases since atomic radius decreases in a period. Electronegativity increase. So if you take lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, which is more electronegative? Fluorine. Noble gas you no need to consider because it is having completely filled configuration. So among all the elements, among all the groups, 17th group elements are having more electronegativity. In that, from top to bottom, it decreases. So what is the which element is at the top in 17th group? Fluorine. So 17th group elements are having more electronegativities than all the group elements. In that way, fluorine is more electronegative. So highest electropositive element in the periodic table is fluorine. Here electronegativity increases. Table is fluorine. This is about period. Next one in group. Next, one more point I would like to give here. Electronegativity increase, non-metallic character increase. Non-metallic character increase. So oxides of these non-metals are acidic. As electronegativity increases, acidic nature of oxides also increase. Increase from left to right. Next one, in a group. In a group. What happens, students? Electronegativity decrease, opposite to the period. From top to bottom. Atomic radius increase. So if you take chlorine to bromine, iodine, chlorine is more electronegative than all. Electronegativity decrease. So non-metallic character decrease. Non-metallic character decrease, and acidic nature of oxides decrease. Nature of oxides decrease. Example, N2O3, 15th group elements oxides I am taking, P2O3, AS2O3, Sb2O3, Bi2O3. Which is more acidic, students? N2O3, because nitrogen is more electronegative. More, if central atom is more electronegative, its oxide is more acidic. So it decreases. Acidic nature decreases. So acidic nature decrease means basic nature increase. That and all you can write. Next, valency. Valency are also periodic property only because it change from period, group to group. Combining capacity of an element. Combining capacity of an element is called valency. If you see group numbers, their valencies. First group, valency 1. Second group, valency 2. 13th group, in between 10 groups, there are transition elements. 3. 14th, 4. 15th, 3. 16th, 2. 17th, 1. 18th, 0. So here, across the period means groups, no? 1, 2, 3, 13, 14, 15 means period only, according from left to right. Valency, first it is increasing and then decreases. Up to 4 it increases, then decreases. Valency. If you take it is in period. If you take group, or to tell student, in a group, valency remains same. Means same group elements are having same valence. All first group elements valency is 1. All second group elements valency is 2. Same group elements are having same valency. Same valency. Okay. So already I wrote no. First group valence is 1. Second group is 2. Those are the common valencies. Decrease. Okay. So valency is also one property. Last conclusion I am going to give students. So overall changes, how to find out AI triple E. Earlier it was like before JEE main. Now it is JEE mains. Earlier it was same JEE mains. They used to call AI triple E. All India Engineering Entrance Exam. Here anyway they are not using. We will use here. A for atomic radius. I for ionization energy. E for electron affinity. This E for electronegativity. Last E must be electropositivity, students. So in a period, A and E decrease. First one, this one, last one decreases, rest all are increases. In a group, it is ulta. A increases, I decreases, E decreases, electronegativity decreases, electropositivity increases. This is the general change trends. There are some exceptions already we discussed. Generally put. This is about periodic classification and properties.